And I think we are live. Let's take a look. Awesome. Hey everybody, good morning, GM. Hope everybody's having a good morning. Thanks for tuning in. I'll be going over some basics on how to deploy smart contracts to the Hedera token service. If you have any questions at any time at all, definitely feel free to just throw them in the chat here. I'm happy to answer any specific questions that anybody's got. And without further ado, I think we got a lot to cover, so I'm going to jump right into it. This is my development environment that I have right here. I know I have a little bit of stuff in here already. Most of it's just from an npm init. There are these three smart contracts that I have in here. And so to deploy a smart contract to Hedera's network and use the Hedera token service through that smart contract, you need these three smart contracts if you want to use the Hedera token service through your smart contract. And I will show you where these can be found. I'll drop a link right here. I have them in the docs. There are links to these files right here. I'll throw that in the chat for you guys, just so that anybody can use that and knows where that is. So my kind of agenda for today is we're going to write a smart contract that can mint, associate, and transfer tokens on the Hedera network. And then we're going to deploy that smart contract. So if you guys are here, I assume maybe you're a little bit familiar with kind of smart contracts and like programming with Solidity. If not, just throw a question in the chat. Like I said, super happy to help anybody answer some questions. But what I have so far is I just have kind of some boilerplate for my contract. I'm using the 8.11 Solidity compiler, and then this is where we actually import these other contracts. So we import the Hedera token service.sol and the response codes.sol. And both of these use the interface of the Hedera token service. So that's why we need these three. And this Hedera token service.sol, it actually has a bunch of different functions that we can use predefined so that we can interact with the Hedera token service. And we're going to pick three of them. So the first one we're going to do is mint. So we're going to make a function right here, and let's call it mint. We'll call it mint fungible tokens. And this is going to, if we're not quite sure what we need to give this, what we're going to do is we're going to look in the Hedera token service, and we're going to look at, we can search a mint token, and it looks like we're going to need a token address, an amount, and some metadata. So I think what we're only going to want to pass to this is the token amount right here. So I'm going to go back to and we're going to pass this unassigned int 64 bytes. And this is going to be an amount. And we're going to make this external. And there we go. And then in here, I'm going to make like a tuple values, because if we look in this mint, if we look at this mint token function that we want to use right here, it is going to return it's going to return a response, a new total supply, and these serial numbers. So what I'm going to want is I'm going to want to capture these in a tuple when I call this. How are things going? Hey. Nice. Just checking in the chat here. Okay, so what I'm going to do is I'm going to make a tuple right here, and it's going to include these 3 different variables. And then I'm going to use the Hedera token service .mint token, and we're going to pass it in. Let's take a look. We have our contract is going to initialize a token address when we deploy it through our constructor. So let's use that for our token address. And then let's use our parameter amount for the amount. And actually for this metadata field, let's just make some new bytes. Okay, nice. So far so good. Now the reason it's giving us these syntax highlights is because we're not using these variables yet, but we will. The next thing let's do is let's check if the response code, let's just call it response. Let's check if the response does not equal Hedera response codes dot success. And otherwise we will revert with the error mint failed. So we have a little bit of error checking, and this is all we need for our mint fungible token function. So we can cross this off our list of tokens. Now we have 2 other functions we want to make. We have an associate function. Let's take a look at the associate function here. So this is going to be similar. So we're going to make let's call it token. How do you spell associate? Associate. We'll make it external. And similarly, if I want to use the associate, token method here, I can see it needs an account and a token to associate that account with. Now, we're going to already have this token ID that this contract is going to handle through our constructor. So what we can just do is we can just make it take an account. So we'll pass it in an address. If I can spell account. And then let's take a look and see what it's going to return. It's going to return a response code. So we can just say that we are going to get a response code. And our response codes we can see right here are integers of 256 bytes. So we can do this, and then we can call the Hedera token service, and we're going to call the associate token. And for the account, we're going to pass in our account variable. And then for the token, we're going to use our token address that we have right here. And I'm actually going to just copy and paste this response code, just in case if it doesn't work, we want to have the appropriate mechanisms in place. Except this time we're just going to say associate failed. Okay. And for those of you guys that don't know, you're definitely, Abbey Road, you're definitely more than free to throw some questions in the chat. For those of you that don't know, in Hedera, in order to interact with a token, you have to associate it to your account. So that's why we have this token associate method going on right now. But yeah, like I said earlier, if anybody has any questions, just throw them in the chat. I'll be happy to answer them and go into depth about any of that. Without further ado, let's get going on our third function in our contract. We have our mint, we have our associate, and now let's look at our transfer. All right, what are we going to call this? Let's just call it token transfer. And we'll make it external as well. And what is our token transfer going to have? It's going to have an address of a sender, an address of a receiver, and an amount that's going to be 64-byte integer. And if you're wondering how I decided to do that, I can go to the token service again. I can look at a token transfer. And here we have actually, I'm pretty sure this one's called transfer token. Yeah. So there is a plural one if you're transferring multiple tokens and a singular one. And we can see that it's going to need the token, the sender, the receiver, and the amount. We don't need the token because we have this in a state variable. And then we can see it returns a response code. So in the logic of this function, we can kind of do something similar where we have a response code. And we're going to set it equal to the token service. And we're going to use transfer token. And now we can see we have all of these parameters. We can throw in our sender, our receiver. Did I spell receiver right? Though, let me just E before I that. And then the amount. And then I'm going to put the same thing to check if things went smoothly. And I will change this to token transfer. Amazing. So here we have our smart contract that we're going to be playing with here. Let me see. Any questions? Any questions? Any questions? Is it possible? Okay. Okay. Twitch TV. Sorry, I gotta get through all these questions. On Ethereum, reading from Solidity smart contracts is free, no transaction fees. So Twitch TV. That's a great question. And actually, there is a HIP going on right now to kind of decide what the current functionality will be. From my understanding, there's a lot of discussion around making them free by making them mirror node requests. Currently, I think they do cost like 1/100th of a cent. But yeah, that's a great question and something that we want to make free. And if you want to be in discussion of like what sort of features you want on Hedera, there's this repository called the Hedera Improvement Proposals. I'll drop it in here. And if you want to like write a HIP, if you want a feature that Hedera doesn't have yet, or if you want to get in the community and like let people know what sort of functionality you desire, or if you want a specific feature, definitely start a discussion and like get engaged here. Hedera is definitely like really interested in like giving the community what they want and hearing from the community of developers and making their life really easy. Okay, Abbey Road. Does this run under Node.js? Okay, we will... You don't have to give the IP Abbey Road. We're actually going to get into that right next. So here, let me show you. There are a variety of SDKs. I will be using the JavaScript SDK, which does work with Node. I have this file with a bunch of comments basically about what I'm going to do. Basically, I'm setting an operator ID, an operator key, and a client. I'm configuring a client to have the operator ID and operator key that I set right here. Now this is a Hedera client. This is from the hashgraph SDK. All you got to do is install this and then import the modules that you want to do. And then my keys are in my .env file, which I'm not going to show you guys. And even though our client is just for testnet, just because it's good practice. And this is empty. I actually do have 2 helper functions down here, but don't worry about them because I'm not going to use them immediately. But yeah, we can see this right here. We can run this and it'll say fight. I have this console in the beginning, just for an example. And so what we're going to do is we're going to have 4 steps here. First, we're going to need to compile and get our contract bytecode. So we've actually finished this first step. We have written our smart contract. Next, we're going to compile and get the bytecode. And we're going to load the bytecode into a variable. Next thing we're going to do is we're going to create a fungible token and set the admin and supply keys so that we can transfer those keys over to the smart contract address. Then we're going to create the smart contract. This involves deploying the bytecode to the Hedera file service kind of as a NIT code, and then deploying from the Hedera file service to the network. And then we're going to execute some functionality in our smart contract. So far, so good. Anybody have any questions? Oh my God, I'm all out of water. Okay. So the first thing we're going to do, what we're going to do is we're going to use the Sol-C compiler to compile our smart contract. And I'm pretty sure it's actually Sol-C.js that we'll be using. And then you put the path of the file you want to compile. And then you can either specify with the bin flag or I think I'll run it, or the ABI flag, if you want either the binary or the ABI. So I'm going to grab the binary, and we'll get a warning because we have those unused local variables, but that's totally fine. And now you'll notice we have 4 files here. Now, 3 of them are actually empty, and we're not going to actually need these, so I'm going to delete these 3. These are from these other contracts. But we do have the binary of our contract minting sol, our minting binary. So this is great. So we're just going to keep that right here. And then we're going to import the FS module. And if you don't know this module in JavaScript, it's like really, really great. It allows you to basically read a bunch of different, I'm pretty sure FS stands for file system, so it allows you to interact with file systems on your machine pretty nicely, which is great. So you're going to grab that. And then what we're going to do here is we're going to say that we're going to make a bytecode variable, and this is just going to be fs.read file sync. Read a file synchronously is what this is saying. And we're going to pass this the file of this. So I'm going to actually copy this file name. And this is our binary, right? And so now we have the bytecode read into this variable, right? And this is actually all we need. So we have successfully written, compiled, and gotten the contract bytecode, right? Success, success. Sevens, good question. So currently, so all of our smart contracts can work with ERC20s. We have like the full EVM compatibility. So if you want to use smart contracts on the network just like you would regularly, you totally can. Now, what we're building right now and are continuing to release features on is integration with the Hedera token service through our smart contracts. And these interactions are preferable because our token service allows for a lot of different programmability, and the tokens on the Hedera token service on the Hedera network are optimized for our network and like super fast and have like really, really low fees. And so that's what these Solidity files are right now. And currently, I think there are 10 supported calls with the Hedera token service. But usually one of those is plural and the other is singular. So I think in reality it's a lot simpler. It's like 5. But this is the existing functionality that we support with the Hedera token service. And we are definitely working on integrating full support of the token service to our contracts, and that's actually like next up on our roadmap here, as well as supporting JSON RPCs, which means we will be able to integrate with Ethers.js and Hardhat and existing Web3 development tools, which is going to be awesome, and I'm super excited for that. Fused Superfox. In the future tutorials, could we get an example of how to go about converting a Solidity file that runs on ETH to Hedera? That's a great question. We can definitely work on that, 100%. I'll definitely work on some content. The short answer is you don't actually need to change anything. You can run the exact same smart contract on Hedera that you can on Ethereum. the long answer is if you want to make it leverage a lot more of the benefits of Hedera, you need to replace the ERC20 functionality with the Hedera token service functionality. And to do that, you would use the HTS precompile stuff, which we're continuing to add features to. Brian, how are you able to use Hedera with the RINC-B ETH testnet, or should I think of it as a separate blockchain? Yeah, so actually Hedera is a layer 1 protocol, so it's a totally separate network. It's a layer 1 network. If you want information about Hedera, here's some information, but it uses a novel consensus mechanism that allows for really high speeds, really low throughput, and actually really low energy cost too. And our fees are actually pegged to USD, which is nice. So as HBAR, our native token, increases in value, our fees are actually still predictable and the same. Okay, so I'm just going to run our code and see everything's working. Oh, need to save the file. It's like, why didn't anything work? Okay. Finish step 1. Amazing. So next thing we're going to do is we're going to create a fungible token and set the keys. So what I'm going to do here is I'm going to make a token called our token. And this is going to await a new, what we're going to need is the token create module from the Hedera token service. And what we're going to do here is we're going to set the token name. And because this is with the Web3Con, we'll just call it Web3. And then we'll set the token symbol. And this is also going to take a string. I'll just put W3 as our token symbol. And if you want to know what all of these parameters are available to you when creating a token, I'll throw a link to our docs on where you can do this. Yeah, so here's all the different fields, and then it shows you even which ones are required and which ones are not required and what they all do. So I'll throw this in the chat as well for you guys. Okay, so back to business. Set decimals. This is like how much you want your token to be divisible by. I'm actually going to set this equal to 0. Just because, for the sake of this example, we don't need. I'm going to set the initial supply equal to 100. And I'm going to set the treasury account ID equal to the operator ID, which is, if you remember, the operator ID is from my account in the .env file. I'm going to set an admin key equal to the operator key. And then I'm going to set a supply key equal to the operator key as well. And then I'm going to freeze this. Supply key, oh, it's because I needed to set. And then this has capitalize. And then we're going to freeze this with the client. And we're going to sign this. This is going to be a transaction, so it needs a signature, right? And we're going to sign it with the operator key. Okay, awesome. So now some things we can do to check if this went through and like get the response code and get information on this. What's our token's token ID, right? What we can do is we can say submit token, And this is going to await. First of all, we actually haven't even sent this to the client. We've just frozen it and signed it. Frozen it and signed it. This is our token, not out token. So first things we gotta do is we gotta execute this transaction with the client. So next thing we're gonna want to do is get the receipt. EI. I always forget how to spell receipt. And this is going to equal our submit token, our token execution, and we can just run get receipt from the client. And then from our receipt, we can make the token ID, right? And this is going to be our token create receipt dot, we can just grab the token ID from our receipt. Pretty nice. And then the last thing I'm going to do is I'm going to get the token ID. We're going to get it in Solidity. So we're going to say token ID Solidity. So this is just going to convert it to output of a hash, right, for the address type. And we can have this to Solidity address right here. Amazing. So the next couple things that we're going to want to do here is let's log what we have so far. I'm just gonna say as a sole address in case hashing is confusing to people. To be fair, the indoor functionality of the KEKAC 256 hash is not simple by design. Okay, awesome. And then let's uncomment our finish step 2. Or, actually, let's not do that yet. We actually want to do some queries and upload. Let's actually upload our contract to the Hedera file service. Okay, so the next thing we're going to do is let's do a token query so we can get some information about the token, right? And I'm going to use one of my helper functions here, but I'm going to check in on you guys, see if there's any questions. Duda Hunid, I don't know exactly. I do know this is being recorded, and it is in our best interest to make this recording available to people. Other words, it definitely depends on like people that are not me on the Hedera team. It might go on the YouTube stream. It might just be continue to be made available here. Okay, so back, let's make a token info, and I'm just gonna number these info queries. I'm going to use my tQuery function on the token ID. And then I'm going to log that our supply of W3 token is actually, let's make this use some string interpolation right here. Let's token info 1. And what we can do here is we can get the total supply. And then just throw a new line in here. So let's run that and see if that works. Finish step 1, nice. Token ID, okay, so we're getting a JSON object. So what we can do is we can just toString this. And we can run this one more time. Got our token ID as a Solidity address and total supply, and things are looking good. So we have successfully interacted with the network, created a token, and gotten some information about our token. Now the next thing we're going to do is we're going to do a file create. So we're going to need the file create module. So we're going to say, we're going to call this file create transaction. And this is going to be a new file create transaction. And what we're going to do is we're going to set the keys equal to the operator key. Nice. Next, we will submit this transaction. So file create submit. And this is going to await the file create transaction dot execute with the client. And then we're going to get the file create receipt, our receipt EI. From the client. And then we're going to get the file ID, right? And we're going to call this the bytecode file ID, right? And this is going to be the file create receipt dot file ID. And actually, I'm going to put the await right here, so we don't need it right here. Nice, so now we have the file ID of a file we think, and now we're going to append. So we're going to need the file append. And if you're wondering why we didn't all just do this in one time, is because sometimes you have to chunk it up. And so it's a lot easier to just create it and then append it, depending on the file's size limitations. However, I think in the future we will build tooling just to make this all like clumped into one API call, so it's easiest for our developers. So same thing, we'll create a file append, and this is going to be a new file append transaction. And we're going to set the file ID, which we have right here as the bytecode file ID. And we're going to set the contents to be our bytecode that we got of our contract. And then we're going to set the max chunks. I'm just going to say 10 to be safe. If you do get an error here, you can, depending on the size of the contract you're deploying, you can adjust this. And then I'm going to set a max transaction fee. So since I'm chunking it, there could be potentially a slightly more transaction fee. And this is denominated in the network's native token called hbar. So I'm going to use the hbar module. And I'm just going to set it to 2 hbar, like super low. 2 hbar I think is like 40 cents. Okay, nice. So now let's do a file append submit. Execute this with the client, same kind of flow. And let's make a receipt. Don't forget my weight. And then what we'll do is we'll create some logs. And I'm just going to log the response code. Okay, let's see if this worked. Chunking and appending the file. Let's see if you guys got any questions while I'm here. Any failing issues when doing a transaction on Hedera? I am not quite sure what you mean by that. There could potentially be any number of issues depending on how you're submitting your transactions to the network. There's definitely incorrect ways to interact with the API. Part of programming is, also just working through your own bugs. But once the transaction gets to the network, usually there's no issues. Our network's pretty stable, if that's what your question is. Okay, nice. We got the success response code, which is awesome. I'm gonna actually remove this new line character, since console.log sort of does that automatically. So next, let's go on to our contract create. So we are going to need the contract create module. So same deal, we're going to make a contract create tx and it is actually pretty simple. What we're going to need here is there's going to be 3 parameters that we're going to pass to this module. Excuse me. A little early still for me. So one is we're going to set the bytecode file ID, right? And we have this from our file create, which is awesome. Next thing we're going to do is we're going to set the gas. Now, gas on Hedera is a lot cheaper than gas on Ethereum. I think it's like 10 times cheaper on Hedera. If you're unfamiliar with the concept of gas, basically gas is a measurement of computation. And so when you use a distributed computing environment like the EVM, for example, the amount of computation that is going to be executed by the network validators when they execute this transaction is measured in gas. And then gas has a price, which corresponds to different transaction fees, and the price of gas on Ethereum is more expensive than it is on Hedera. So this is going to be really low. But I usually set this to about 3 million computational units. There's probably ways to set this lower, but unused gas will totally be refunded in Hedera automatically, which is nice. So I usually just create an upper bound and am good with that. So next we have to set the constructor parameters. So if you remember in our contract, we have a constructor that just is a token address that sets this state variable token address to this token address. Now, these do need to be in a of a contract function parameter type. Oh, nice. It just did that automatically for me. And these are going to be, you can set what's the type of parameter type. So I'm like add address, and I'm going to put the token ID as a Solidity address here. So that's nice. Things are good there. And that's all you need to do. So let's kind of do some similar stuff where let's submit this this contract create transaction to the network. And then last thing we're going to want, let's get the contract ID. And then let's also get it as a Solidity address. Okay, and then let's log these. Okay, nice. Awesome. So next two things we want to do is we want to get a do a query on, we're going to just call this token info 2, and we're going to make a T query of our token ID. And then we're going to get our supply key of our token. So our token supply key and so this is basically going to, we'll see what's going on here. Wish I filled up my water bottle before the stream. I'm thirsty. This needs to be toString, still a JSON object. Ooh. So we get the public key of the supply key right here. So next thing we're going to want to do is we're going to want to update this to the smart contracts key. So we're gonna make a token update. Token update transaction. And we're gonna set the token ID of the token we are going to do this to. And then we are going to set the supply key to the contract ID. And then we are going to freeze with the client. And we're going to sign with the operator key. And let's get the receipt. So if you kind of noticed, using the Hedera SDK kind of follows this flow where you kind of build a transaction and then you submit this transaction to the network. So this is the transaction. Okay, nice. So let's get the response code here. So we're just going to get the status, which is the response code. And then let's actually do a another info query. And what we can do here is we can do the same thing where we check in the supply key. But we're just going to do of the third info query. Okay, let's give this a run and see how it goes. Looks like we got an error, and I think it's because we didn't get the token update. Oh, it just needs a new keyword. Await new token update. Actually, we don't need to await this because we're not submitting it right now. We're just building it. And while that's running, I'm going to get going on one of the functionality of calling our contract. So we're going to call this contract mint token update transaction. We got one thing going on here. Let's take a look, see what's wrong. Token update. Maybe we do need the await new. see if that, oh, let's save. That'll probably, although we have to comment this out. Let's see if that works. We are nearing the end of our time, so I want to get through at least a few of these contract executes before we wrap up here. So this is the way that you execute a contract's functions on the Hedera network right here. Thank you, Furcon28. We're doing our best here. So the first thing we're going to need is we're going to need the contract ID of the contract we want to execute a transaction from. Then we need to set the gas. Again, any excess gas is always refunded, so I usually set an upper bound. I usually do 3 million, but you could probably set less. Then we set our function, and the name of the function is taken in as a string. So if we go here, we want to take this exact string, so I'm just going to copy it. And then the second parameter that our function takes is our contract parameters. So I'm going to make a new contract function parameter, and if we go back here, we can see that our minting takes an unassigned int of 64 bits. And I'm actually going to set that equal to 100. So the logic of what we're doing here is we are essentially, I'm also going to set the max transaction fee to about 40 cents right now. So what we're doing right here is we're basically telling the contract to mint tokens. And we're telling it to mint 100 tokens. So let's see how this goes. Okay. That looks good. That looks good. And we can actually verify if this went by doing a token info query. We are on number 4. We can do a similar thing. This is number 4, and actually we're not getting the supply key this time. This time we're just getting the total supply. And this is just the type of that supply variable. Okay. So let's take a look, see if that worked. See if our contract minted these tokens. Looks like everything went through really well. We see we have this success response code and a new token supply of 200. So what I'm doing right now is I'm generating an account. I just generating a random private key and a corresponding public key. And now we can create an account for Alice right now. And what we do here is we set the key of the account. Just one key, pretty sure, not plural. To the Alice private key. And we'll just execute this with the client immediately. And then let's get the response. And then let's get the account ID. So now let's try and use the associate functionality of our smart contract. So what we're going to do is we're going to set the contract equal to our contract ID, and then set the gas. And then we're going to set the function. And remember, the first parameter is going to be our function name as a string. And then the second parameter is going to be contract function parameters. And if we look, we need the account, right? So let's add an address, and let's pass in Alice's account ID, but remember this has to be of a Solidity address form. Just format it a little nicely. Then we will freeze with the client, because we need Alice's signature, right? So next thing we're going to need is to get, I think we can sign right here with Alice private key. And let's see if this was a success. And then let's run this. Guys, I am so sorry. We might have to go a little early. I will make all of this completed code available on GitHub for anybody interested in wanting to play around with it. The last one is just the same exact flow. Let's actually fix this though. This needs to be a new account create. It might even need the await keyword. Yeah, it does. Stop right there. But I am gonna make all of this. I'll actually drop the code for this in the chat right now, in case anybody wants to play around. And use this code. Just make sure I don't have my .env file here. Perfect. There might be one other contract in here that I was playing around called fundme.sol. You can just ignore this. I was just trying to see if something would work and testing some new features. Okay, let's go back and fix whatever thing we're cannot read properties of to Solidity address. Add address. Add address. Alice's account ID to Solidity address. Let's just make a to make our lives a little easier. Let's try this. Oops. There we go. It's missing a parentheses. What does it not like? Cannot read properties undefined. Let's take a look real quick. To Solidity address. It uses the exact same. Do we have the account create? Yep. Oh, I think I spelled that wrong. my proof of being a mathematician is that I'm terrible at spelling. Okay, well, are there any questions so far? Does everybody have any... How's everybody feeling? Well, I never heard of Hedera. I started working on Binance Smart Chain about a year ago. Yeah, well, I definitely can't blame you. There are so many cool projects out there. It is very difficult to stay on top of them. Yep, 10K transactions per second is what we're able to handle right now, which is like really awesome. We're super proud of that. If you have any more questions, feel free to reach out to me or DM me on Twitter. My handle on Twitter, I'll just put it in here, is Waylon Jepsen. Yeah, so Hedera's initially, really kind of catered toward the enterprise DLT marketplace, which is, I would say, probably a strength and a weakness of Hedera, right? Because a lot of different products in distributed ledgers are sort of like almost anti-enterprise in nature, right? So it's nice that we have like a ton of credibility of our like technology and consensus mechanisms, but we definitely want to, if you look at our roadmap, we're going to release community nodes this year, which is going to be great because we're going to decentralize a lot more, and I think that's going to be good for everything. Anyway, if there's no additional questions, I can go back and double check that this went through successfully. If there's no more questions, I'm gonna cut the stream right now. Thank you guys all for attending. I love doing streams because they're interactive and I get to like hear from community people. So I love your guys' questions. I love hearing from you guys. Definitely will be more than happy to answer any of your guys' questions. And I look forward to seeing what you guys all build, not just in this hackathon, but in this coming year. I think this coming year is going to be really exciting in the land of distributed ledgers, and there's going to be a lot of really amazing products built. With that, I'm going to say goodbye. But like I said, DM me on Twitter if you have any questions. Stop the stream.